All right, how you doing, guys?
Hey, we're Plan B. We're Plan B. I'm Dan.
I'm Zach.
I'm Phil.
All right, nice to meet you.
We made Duck Hunt, and it's 2-player, and so we'll start off by just playing, and I'll explain how it works as we go along. So we'll have Zach play over here. And so both the guns have photodiodes in them, and when the screen is displaying color, it senses a 1. If there's no color, it senses a 0. So when the trigger is pulled, it'll black out the background. You can kind of see the flicker on the background there. What that's doing is making the background black, but leaving the duck there. And so the game will detect if the trigger was pulled and if the sensor was detecting. And if those both are true, it knows the duck was hit. And the other interesting part is moving the duck randomly. And how we accomplish that is having 4 states. And there's a method that I can specify a coordinate for that duck to move to. And it'll incrementally move the duck there until it gets there. Once it gets there, it will return from that function call and then get another random coordinate. So the states are split up to 4 different coordinates on the screen, and the top left corner is a smaller random number, and the bottom is a bigger random number. That guarantees that it's always on the screen. So I'll hand it off to Zach to explain about the sound.
I'll explain the sound in the game. Maybe let's turn this up.
Yeah, turn it up so we can hear.
You can hear. So each time you shoot, you can hear the gun play. In this screen, on the start screen, it'll play a song. And the way that's interfaced is here through this MP3 trigger. It sends a low signal when we want to play the sound, or a ground signal. The sounds are saved into this micro SD card, and based on which pin is sending the signal, it'll play that sound. So in the start screen, it'll play the music, and while you're playing the game, it'll make the gun noises.
Alright, the screen flashes the color of the player that it hits. So you see my gun is green. When I hit it, it flashes green.
And the other one's red. All right, very good indication to see who got it.
Alright, now I'm going to explain a little bit about the VGA.
And the processor and everything.
And the processor.
Yeah, just go at it.
So this is how our process works. It's a modified CR16 processor with a few special instructions, mostly just for handling, all of the video instructions. So this is actually an 80 by 60 character-based glyph map with a total of 64 characters that can be written to the screen. These lights are special characters that are based on the pixel clock. You can see that they're actually blinking, and if I pause the CPU, I can pause the CPU and this will actually continue. But the rest of the Christmas tree you can see is actually drawn totally with the glyph maps, and that's a really interesting part of our CPU design, that we have a special glyph map for this, and we can use different characters to generate graphics in 8-bit color. If I pause it, you can see that the sprite's no longer moving and the gun is no longer registering inputs. The reason we implemented this pause is to implement this debug screen. This debug screen actually allows us to pull information live from our CPU. So this is our program counter and all 16 registers, and these are the values as the program is executing. This is the instruction being pulled from this address, and this is the decoded instruction, so it's more human readable. These are the values that are coming to and from the ALU. So you can see the register. This is the A input, the B input, and the value that's going to be written back. These are the values that are going into the ALU, so it'll show an immediate value here instead of the second register here. This is the address that we are currently setting up in our data memory, and this is the value that's being split between the ALU output and the memory. When we have a comparison instruction, then we have our flags that are dynamically set based on that. When we are in the pause mode, we also have the ability to single step through the instructions. So you can see that as I step through, we go to the very next instruction, and the data streaming is live. Here we have a Z flag, which is just showing that we have a
a value coming out of data 1, or that will come out of data 1 from the ALU that is not, that is 0. This flag is actually really important for the jump instructions and the branch instructions. And we actually had a problem in our instruction FSM that was necessary.
All right, guys, this was a very good project. Thanks for all the hard work. See you guys soon.
Thanks.